Hello, Miss. My name is Chin Pai Yu and I'm team leader. And my group member are Ho Bingze, Alan, and Joa Tang Kai Xuan. And today I'm gonna present about Logic 1, Chapter 5. And the first slide is I'm gonna define what we mean by logic in computing. Logic involves the systematic use of reasoning to make decisions. It's crucial in programming and software development because it allows systems to make choices based on defined conditions. We will also touch on basic logical operations such as AND, OR, and NOT, which are foundational to decision making in algorithms. So, AND is requires all conditions to be true for an outcome to be true. OR allows at least one condition to be true for the outcome to be true. And the last one, not negates a condition in return its value. And the next slide is importance of logic in daily life. Logic isn't just for academic settings, it's incredibly useful in everyday situations. By using logic, we can make decisions that are reasoned and structured. For instance, logic allows us to evaluate different options and outcomes, helping us make choices that are consistent with our goals. The structured thinking also let us spot inconsistencies and understand relationships between different ideas, making our reasoning sounder and more effective. And the next slide, importance of Logic 1 in computing mathematics. Logic 1 underpins almost every aspect of computing. It enables accurate calculations, ensures reliable decision making, and powers the core functionality of digital devices. By mastering these basic logical operations, we can build complex systems that perform tasks efficiently and accurately.
Propositional logic. A proposition is a statement that is either true or false. Logic is sometimes defined as science of necessary inference, science of reasoning. Logic analysis won't help you to determine the intrinsic merit of an argument content, but help to analyze an argument form to determine whether the truth of the conclusion follows necessarily from the truth of the premises. Logical connectives. Logical connectives are transitional words and phrases. They mentally link one idea to another. They do not serve a grammatical function. They do not link main clauses of equal value as coordinate connectives do. They do not de-emphasize a less dominant idea as subordinate connectives do. Logical operators. A logical operator is a symbol or word used to connect two or more expressions such that the value of the compound expression produced depends only on that of the original expression and on the meaning of the operator. Types of logical operator: and, or, and not. Logical connectors. These logical connectors are used to join or connect two ideas that have a particular relationship. The various type of the logical connectors include conjunction, means and, disjunction, or, negation, not, implication, if, then, equivalence, if and only if. Logic equivalence. Two expressions are logically equivalent provided that they have the same truth value of for all possible combination of truth value for all variable appearing in the two expressions. For example, if it is raining, then the ground is wet, and if the ground is not wet, then it is not raining. I will eat pizza tonight if and only if my friend comes over, and if I eat pizza tonight, then my friend is coming over. The example expression given is logically equivalent because they share the same meaning.
Let's look at how logic is implemented in the real life. In our daily lives, we frequently use search engines like Google, which includes a type of logic so-called as Boolean logic. And inside Boolean logic, there are some keywords such as and, or, and not. For instance, imagine we're searching to buy a budget laptop, but not a gaming. So we would search for a budget and laptop, but not gaming. And what this does is that the engine will provide results that focus specifically on budget laptops only, while excluding any gaming laptop option. This targeted approach will make sure we get exactly what we are searching for. On the other hand, imagine we're trying to buy a phone case, and we would search for either waterproof or shockproof phone cases. Now what this does is that the engine will make sure that the result will be either waterproof phone cases or shockproof phone cases. Now these examples demonstrate how Boolean logic simplifies our searches and help us make decisions more quickly. Let's look at another example of how logic is employed in the real life. Here, we have a scenario of a user attempting to log into their account using their own credential. Now for the users to get full access to their account, we need to make sure that both their username and password are matched to the system, and only then will they be granted full access to their account. However, there are also many ways to be denied of access. One of it being username simply does not exist. Without the username in the system, there won't be any access given if the account simply doesn't exist. Another way to be denied of access is an incorrect password. You could have your username correct and inside the system, but if your password is incorrect, you will also be denied of access to your account. In conclusion, both username and password must be a match to the system. Only then you will have access to the account. Otherwise, you will be locked out.
So now we'll talk about the truth table. So what is a truth table? It's a breakdown of all the possible truth values returned by a logical expression. So let's begin with the AND. What is AND? Here we have a real-life example to explain it. To enter the university, you have to pass an exam in English and mathematics. Let's imagine that A is English exam and B is a math exam. If you pass both of them, you can study in university. If you pass math but not English, no, you cannot. If you pass English but not math, you still cannot. If you didn't pass any of them, it's obvious you cannot study. Okay, the next one is OR. What is OR? Here we have another real-life example. If the baby screams, you need to give him toy or pacifier. Let's make A toy and B pacifier. If you give him both, true, he will stop crying. If you give him toy but not pacifier, he will stop screaming. If you give him pacifier but not toy, same, he will stop screaming. But if you give him nothing, he will continue screaming. The third one is if-then. Real-life example. It's very similar to order in execution. For example, let's imagine that A is wife and B is a husband. If wife says her husband throw out the trash and he did this, it's true. If she said do that but he didn't do, so it's false. If she didn't say but he did, it's true. If she didn't say and he didn't do anything, it's okay, it's true. If and only if. Real life example. Let's imagine that A is I do my job well and B is I'll receive salary increase. If let's say both is true, I do my job well and I'll receive salary increase. It's true. And if both false, I don't do my job well and I will not receive salary increase. It's a true. But if we say I do my job well and I will not receive salary increase, or I don't do my job well and I will receive salary increase, it's a false. And the last one, not. It's very simple. It's just a negation of variable. True become false, false become true.